I need a jingle. There we go. Boom, boom, boom. Hello and welcome to Practically Clojure with me, John Stevenson. Thank you very much for joining me. I hope everything is working okay because it's been a few weeks since I did a broadcast. Apologies, I've been a little bit ill. And hopefully everything is working. Please let me know in the chat that it's working okay. Otherwise I might have to repeat this broadcast. And if you've got any questions about what we're doing as well, please feel free to put them in the chat or put them into the other channels, which I'll mention in a moment. Okay, so this week, what are we going to do? We're still working on the Brave Clojure. The Brave Clojure book, which has been around for a while. Still got lots of really good content in there, but just kind of showing some different variations, some different examples, and some more modern tooling. So the overall work we're doing is using Clojure CLI tools, but most of the code is kind of similar, and I'm just using some different examples to explain other things as we go along. This so we're looking at chapter 3 of Brave Clojure. Let's switch over to so it's the do things, and we're going to look at all the way down. Whee! That's a bit trippy. Functions. There isn't a link to that as well. So we're going to have a look through functions. So calling functions, how functions differ from macros and special forms. We'll briefly touch on that. We're not going to write any macros, but we're going to talk about using them. Anonymous functions, returning functions, and so on and so on. Okay. Just before we start, just a quick reminder, everything's on the Practicalli website, so you can go to practical.li or practicalli.github.io. They're both the same website. There's all the broadcasts there. There is a Brave Clojure playlist. I haven't added it to the web page yet, but I will do that. But if you go onto YouTube, you'll be able to find it. And there's all the books. If you want to reach out and ask me questions after the broadcasts, then feel free to use any of these channels as well. And thanks to everybody who's been supporting me. And there's an echo. Oh, thank you for pointing that out. I think it might be using the wrong settings. Oh, yes. Let me switch over to let me switch over to the different microphone. I think it's using the wrong microphone. I knew there would be some issues when it started. So, oh, I don't want that. Can be disconnected. Oh, I don't want that. There we go. I was listening to my own videos earlier on, and then sound. Yes, apologies. There we go. Should be fix that in a moment. There we go. Hopefully that sound should be much better now, because that's my nice microphone here. Instead of, I'm not quite sure where it was picking up from otherwise. No, it should be better now. Okay, yeah, so yeah, feel free to reach out to me. And again, thanks to everybody who's sponsored me and continues to sponsor me, especially Cognitech and Nubank, but also every individual person as well that's reached out to me and sponsored me. It's a good way to keep my motivation going, knowing that people are enjoying the content. Okay, so let's have a look at Brave Clojure. And again, you don't have to be brave to do this. You just have to have a little bit of time. And so functions, Clojure is a functional programming language. So one of the main concepts is the function. And in other programming languages, you may be used to methods that you're calling within a class. It's not that dissimilar. It's basically a function is a usually smallish piece of an algorithm, a smallish piece of code that does some behavior and returns a result. and that result is always going to be a value. So no matter what function you call, you're always going to get a result. It might not be the result you wanted, but the REPL, using the REPL can actually teach you and show you how to use those functions, because you can kind of see the results straight away as you do them. So let's jump over to the editor. If I can remember, oh yes, remember how to use my computer. There we go. And so I found the project I was working on. I will share this, honestly, I will actually share this at the end of this broadcast. I think I did promise that in previous broadcasts, but I forgot. So this is a section. I've got a function. I've got a namespace for functions. Let me just show you the structure of this. Oops. Why is that not? Gmax rubbish. What's going on now? No. There we go. Yeah, so we've got here our project, which is called Getting Started. I've got a function namespace, which has got all the function stuff in there, and some of the early work is in data structures and Getting Started sections. So I'm going to create a namespace for kind of major sections of the book, just to make it easier to find things. Calling functions. So we've already seen some of this in the previous videos that we've covered, especially the last two videos. We've been calling functions in Clojure, and that's a very simple syntax and consistent throughout the language. So to call a function, you just put it as the first thing inside a list, with the list being the round brackets or the parens. And you can supply no arguments in this case, so you can supply a single argument or multiple arguments or almost infinite number of arguments. Well, if it's a lazy sequence, then potentially there's no end to that sequence as well. So you could pass infinity into a function. It might take a little bit of time to finish. Like infinity plus infinity is infinity, I believe. But so here's some examples. So I've got the REPL running already. So I'm just using Spacemax here, but any editor will do. You can also do these in the terminal REPL UI as well, but it's nicer to do that inside an editor, a Clojure aware editor. And so I can evaluate this this function call, which is the first element is plus, and this is the doc string for plus. So you can see that plus will return the sum of numbers, and if you call it without any arguments, it will return 0. And the doc string is kind of, and it's like this is showing us the different kind of signatures we can use with the function. So we can call it without any arguments, with one argument, with two arguments, and then with two arguments, but anything else that you pass will be put into a local collection called more, and then it will be basically just passed through. So you can kind of have as many arguments as you want to the plus function, and it will just work through them all and basically add them all up. So if we evaluate this, we get a value of 51. So it's very simple. Hopefully that's easy enough to understand if you've watched any of the previous videos. And instead of just having like simple arguments to a function, we can also like pass in functions, a function call as an argument as well. So this is a function call that's going to add 1 with 2, and it's going to evaluate that function call first, and then it can pass that as an argument to the very first element of plus. So all these arguments here, so these function calls need to be evaluated individually first. So that's what Clojure will do. It will go and evaluate all these nested functions, and then it will pass that, like return the results, and so then you will just have something that looks a bit like that, and then it will return the values. It will basically, it will then call the plus with the values it's returned, and you get the overall result. So this was 51. So I just evaluated that as a comment. And this is hopefully going to do the same. And we can also check, we can also go in and evaluate. I'm just going to evaluate that particular function. So if I do EE, so that's returning 5. What I can do with some editors will also support this. You can actually replace the value of an expression with its results, and that way you can kind of sometimes it's useful to do that to help understand what a function is doing, especially if there's quite a few nested expressions in there. So I can use in Spacemacs it's comma E and then W, and so that replaces the result with it replaces the function call with its result, and I can do that with the rest of them. 48 over 6, this is a ratio type, so this is not a function call, this is a value, this is a ratio value in Clojure, and I can evaluate that, and it's actually going to, because it's a whole number and it won't lose any precision of the value, then when I evaluate that it'll just return that as back as an integer number. And we can do the same thing for there and there. And now we get, it's very easy to understand what it's doing. It's just adding up a bunch of numbers. So evaluating and replacing something in place is a very handy little technique I found when I was learning Clojure. And I still find it very valuable now. We're working on a much larger project at the moment, and some of the older code is a little bit harder to understand. So we're actually just, and some of the test data is a bit opaque. So we're actually just pulling that in and making it nicer just by replacing some function calls with the actual value, and then we can see exactly what it's doing. No questions so far, so hopefully everybody can hear me. Oh yes, there's quite a few people watching, so thanks very much. So that's the basics of calling functions. That's all, hopefully the very simple stuff that you kind of know already. Where are we? Whoop. Oh, yes. Oh, I'm on the wrong place. Oops. Wrong browser. So yeah, this is coming up with some, this is just introducing the same kind of examples. There's a very interesting example it might be worth just talking about in the book. It's got this or plus and minus and 1, 2, 3. So I put that into the editor as well. So yeah, so this, what does this actually mean? Well, if we evaluate this, we get the results. So that kind of suggests it's adding 1, 2, and 3 together somehow and getting the results. And we've got this OR in here. So if we look at the OR itself, it's actually returning the function. So this is showing it's returning the fully qualified function name of plus. Let's just put that as a comment. So it's returning a function, and the function the full function name is Clojure.core, because that's where the where the function is defined, and the function name is plus. And we could go in and we could go with Clojure docs. Clojure doc. No, cider doc, sorry. Is it that one? Yeah, there we go. So go look at the doc, and if we actually go and look at the file, we go and look at the source code of that function. So we can see that this is in the core CLJ file, and so this is the Clojure.core. Oops, there it is. Yeah, there's Clojure.core plus function. So this is its full name, and we can see that it's got different ways of calling it. So these are the different, what we call arities. So it can be called with without any functions, it's just going to return 0. It can be called with a single function, and it's just going to cast that number to X. So some of the Clojure core stuff is quite nice to read. Some of it is kind of underneath a bit lower level and trying to optimize things. And if you pass it with more than 2 arguments, it's basically just going to go and add the first 2, but then just kind of iterate over the rest of the arguments and just add them all up to the first 2 that it gets as well. So you don't have to add like an infinite number of sections to this function to take care of like how many possible arguments somebody might try to add up. And this is quite common kind of thing. You'll see this a lot in the Clojure core and in Clojure as well. Is there anything? No, I don't think there's anything else I wanted to add on that. Let's quit. Boop. If there's a few kind of distracting things, I'm using Clojure LSP, which adds a lot of stuff that I'm not yet quite used to yet. So it does add a few extra bits and bobs, which I'm not quite comfortable with yet, but hopefully it's not too distracting. So what's this OR doing? So I was going to return the first like truthy value. And so it's returning plus, but plus isn't like a Boolean true or false, because if we actually do the true predicate as a function called true question mark, which will pass the argument of the plus function. So we can pass an argument, we can pass a function as an argument to a function, and then we get a value back. And so in this case, it's saying that that's not true, it's false. Because, well, that's true because the true is checking for an actual Boolean true. So if we did true, oops, that's not quite right, is it? There we go. So if we do true as in the is this true function call and pass it the true, which is a Boolean argument, then that's going to be true. And if we do the other Boolean argument, which is false, then obviously that's going to be false. So there's the kind of Boolean true, is it true, is it false kind of thing, which is a specific and like an explicit value, a literal value. But then there's this idea of truthiness. I think we covered in the video 96, where we actually used kind of the essence of whether something is like a positive or a negative result. And so we can actually use pretty much most values in Clojure are truthy. And so while they're not a Boolean true, they are true. They are kind of truthy. They're a positive kind of result or positive value. Whereas if there's things like nil and false are falsy. So if we evaluate if, so our condition in the if statement is, well, it's a plus. And if we evaluate that, we get the truthy because it sees plus as a positive, as a truthful style value. So that's what it returns. If we change this to nil, then we get false because nil is falsy. It's saying, well, the nil is a value, but it's kind of indicating there's an absence of like a meaningful value. Nil has its kind of meaning that, okay, we didn't find a value that we were looking for. So there's no kind of business context. There's no kind of no kind of context of what we were trying to get. We return. It's kind of indicating a value of what we didn't find what we were looking for. So we return nil, and that acts as falsy. So let's leave that there. Let's put that as a different example. So when we kind of think about this, then we can see that the first truthy value that OR is going to return is going to be the plus. So then that returns that. So we can see that this is, if we do the dew, then that returns plus. I'm not sure if that will. Yeah, well, it doesn't quite do what I want it to do. Yes. There we go. Oh. Yeah, so it returns Clojure core plus, and then we use that to pass the arguments to, and we get 6. There we go. And other examples that the book covers is like and, so that's also it's going is going to in the same way or returns the first truthy value, then and is going to return the last truthy value. So it's going to return. It's going to see that this is true. So this evaluates type to a truthy value because it's returning. In this case, it's returning true. So it's actually returning a Boolean. And plus, again, as we've seen, is a truthy value, so it will return that, and then add all the numbers up. And first is just getting that from, is getting the first element from that, so it's going to return plus and return the numbers. And I think the point of these examples is that the result of this function is going to be a plus. So the functions are always returning those values, and then those values can be used as part of the expression. If kind of nested in another expression, they can be used that way. And it's showing that this is returning a value that we can interpret as a function call, like the plus, and then we can then call that that expression because it's Clojure knows to call that first thing as a function. And functions, yeah, so functions can take other functions as arguments. So we've got the classic map inc argument example here. So we're just passing this inc function, which is just going to add 1 to integer values. So we've got this collection of integer values here, and we're going to add 1 to it just by passing each value in turn to the inc function, and then map collects the results of each of those calls and returns them in a nice sequence. And so it's returning a list, a sequence of values rather than a vector. But it's the same. So like as we've kind of mentioned before, a vector and a sequence, if their values are the same, then they are the same as well. So it's Clojure map and other functions in Clojure are kind of like sequence functions. They work on sequences, so they'll return sequences as well. But you don't have to convert them into a vector because it's the values that are important, and not the container that they come in. So I just need to quote that, so it will not treat it, because this is a list, it would treat 1 as a function call, which we don't want it to do. We just want to treat that as like individual values. So you can short circuit the normal way that Clojure works by telling it to not use this first element as a function call, and we can see that those two things, because the values are the same, then they are the same. Here's a question for the audience. Yes, all these videos are live streamed to YouTube, and they should be immediately available because I've got the digital video recorder happening, but it might do some processing as well to get the things out. So they're all on YouTube. There's about over 100 hours now. Oh, feel free to ask me if you can't find what you're looking for. Feel free to ask, and I'll point in the right direction to which video to have a look at. And let's do something more interesting. These have been very, very simple examples. So let's do something more interesting. So we've got a stock market portfolio. So these are all the stocks I've got, and maybe I can't quite remember what stocks I have, but we're actually putting them into a name. We're actually giving this data structure, which is a vector of elements, and each element is a hash map. So a hash map, and a hash map has these key value pairs. And so what we're doing is basically saying these are the collection of stock prices, stocks I've got, and I'm just binding that to the name portfolio so I can use it in different parts of my code without having to type in the this whole data structure over and over again. So we evaluate that, and it's giving it a fully qualified name, and then we can use this map. And we're using this keyword as a function here, and a keyword is the same as doing, if we want get portfolio, and we want to get the key, let's say ticker. This will give us oops, actually we want to do first on there, don't we? Because it's a collection of maps, it's not a map itself. If we took, let's just see this, let's take this and replace portfolio this, boop. Okay, so we want to get from this map the value ticker, and so it's returning CRM, and that code is the same as if we do, we can short circuit this a little bit. We can use a map as a function, and it returns it, and we can also use the keyword as a function because the keys are keywords. So this is a special property of the keyword in Clojure. Oops, I might have to turn that highlighting off. It gets a bit annoying. Sorry. So that's for an individual map, but in our data structure we've got a collection of maps. A collection of so we've got a hash map that is we have a vector that is a collection of these individual hash maps. So this is a good way to actually just have a collection of kind of unique values that are expressed as a hash map. And then I'm using the map function, which is going to take each of these maps in turn and pass them to the ticker. So this is like get me the ticker, get me the value of ticker key in each individual map. So if I do that, then it's going to return a sequence. So again, it's returning a sequence of all the values from each of the tickers in the map. So that, again, this is another example of I'm giving the map a function and a collection of data, and then it's using that function over the collection of the individual elements in the collection of data and returning a result. And then with here's more explicit kind of example. So here I'm defining a function. We'll look at defining functions very, very soon, in a few minutes. So I've got this function which is basically going to take the stock price. So it's basically going to take each individual map from our collection, and then in that stock price, in that hash map, it's going to associate with the open keyword. It's going to associate a new value. So basically, it's changing the value that's there. So if we wanted to, at the end of the day, if we wanted to, or before trading starts, we wanted to update the opening price of all our trades from basically what the last trade was. We can go in and get the last trade in that particular hash map, which is stock price now because we passed it in. So that's the one of the individual maps, and then we get that value. And then we assign that to, or we bind that to the open key, and we're kind of mapping this function over the portfolio data structure. So we can see that function. So this is a function that we've defined ourselves that we're using with maps. So we can use functions from the Clojure itself, or we can use functions that we write ourselves. And we can do this because all functions are actually just returning a value, and that kind of speaks to the composability of Clojure, and so you can build your own kind of abstractions very, very easily. Okay, so that's calling functions, and we're going to look at defining functions in a second, but just before we do that, just a brief mention. So the book talks about this idea of special forms. You don't have to get this straight away. It did take me a while to understand special forms, but special forms are basically the functions that actually make up the language itself. So the core, the basic tools of Clojure. And we're going to look at Clojure special forms. There's only a very small number of these, so things like def and if and do and let and quote. I think there's around about 12 of these now, and so these 12, think of them as functions for now, but these 12 special forms, from them we can create all the rest of the Clojure language, either as functions or as macros. Oh yeah, so this is it. So this is basically every kind of form you need to build Clojure, or pretty much any Lisp actually. I think a few extra are for Clojure because there's things like Java interop, things like throw, and so on. But yeah, it's a very small amount of these forms you need to be able to build the language. When you're writing Clojure, then I think the thing to know is that these special forms are they can have slightly different evaluation rules, and they can't be used as arguments to a function. So you can't, while you can kind of call if with just one path, normally you would kind of have like two paths. False. So with normal function, you would have to give like all the arguments that it was going to use. But if can have like a very flexible number of arguments, it can either have like the so you have the condition, and then it can either have just the true path, or you can have the true and false path, which is a little bit different to calling most functions. And you can't use if as a kind of you can't map an if over something. We can't pass that as an argument to a function. But most of the time you don't want to. You'd use these as part of the logic inside of a function anyway, and def you would use outside of a function that way, but you can't pass them as arguments. So if you do come up with errors, it might be that you're doing that. I guess I don't really think about special forms that much unless I'm explaining the programming language to people. So again, don't worry if you're not fully understanding that yet. Let's look at defining functions because that's more interesting and more useful. So we have seen in this example here, we defined this function here. Let's just bring that down as an example of an anonymous function. We'll talk about what that means in a moment. So the normal way to define a function is with defn, and defn is actually a macro. So a macro, in simple terms, is just a template we use to generate more code. So you can actually extend the Clojure language if you want by writing a macro, although the first rule of Macro Club is don't write macros. There are some limitations. Obviously, macros are not composable like functions are. So if you can do it in a function, you should use a function. But if there's a real kind of need to do it as a macro, if you need this template to generate something slightly different, or if there's like an obvious kind of improvement to the readability and maintainability of a Clojure code you're developing, then writing a macro can be a useful convenience. And that's what the defn macro is a convenience on this idea of defn, def and function. So let's kind of delve into that a little bit first. So here's an example from the Brave Clojure. So we've got this defn function, and we're giving it a name, and then we've got a doc string, and then we've got the arguments that we pass in. So we're only going to pass in a single argument. That could be a single value. It could be a value that is a collection, but there's only going to be one argument in that, whatever that is. And then we've got the body of the function, what it's actually doing, its algorithm as it were, and this is going to generate the value that the function returns. So if you evaluate that, then that becomes part of the REPL process. So that's available in the REPL. So anything that's connected to the REPL can now call this function and pass an argument and then get the result. So if we do too enthusiastic, and so my editor is connected to the REPL. So it's also giving me auto-completion. And I've got a linter that's running in the background that's telling me I'm actually, if I'd call this now, it's using the wrong arity. I've got an invalid arity error at the end there, and it's saying I'm trying to call it with 0 arguments, but it's expecting 1. So that's a nice little bit of extra help from a linter called CLJ Condo. Thank you very much, Borgdude, for writing that. And so if I call this, if I ignore the warnings and just call it anyway, then I get the exception, and I shouldn't really be that surprised. I get the exception because that's what my editor's been telling me is going to go wrong, and it's the same error as well. So yeah, I'm calling the wrong number of arguments. I'm using the wrong number of arguments when I'm calling this too enthusiastic. And looks at things, so it's going to put in it's going to put name inside this string that it returns. So I can use let's just use a string called Practicalli, and so now I don't have any warnings. If I call that, then it's now returning the value, and it's yeah, let's put that in. Okay. Interesting example. And so yeah, so that's so you do get warnings if you've got a linter, or if you run code and you're calling functions without the right number of arguments, then it gives you a very obvious answer, obvious error message. But you can also define functions that take different narratives, as we've seen before as well. So that's one way to kind of solve it. It's like sometimes you might want to just pass 1 argument, you might want to pass 2 arguments, or you might just pass a map as an argument as well, and then basically you just write your function to process the details it wants from a map, and that way you make your functions a lot more flexible. But we were talking about defn as a macro, so let's just delve into what that means. I think if I do, I think I can evaluate this as a macro expand, which is, I think, (em). Yeah, there we go. So this is showing me, if I can make this bigger. There we go. Let's do. No, it won't make that any bigger. Let's just copy that. It's been a while since I did this. Boom, there we go. Is that the right thing? No, that's not the right thing at all, is it? Let's try this again. There we go. That's the one. Sorry, I was macro expanding the wrong thing. So this is what we've written. This is this defn function. And if we expand this macro, this defn macro, this defn template, we can actually see what Clojure interprets this as is a def expression. So we're binding, we're using def to bind this name to enthusiastic to an existing function. So this anonymous function we've got here. So we're actually taking an anonymous function, binding it to a name, and that's how defn works. Basically, it's a quite simple macro. And so this function is going to take name as an argument, and then basically call string and return the value. So we could actually write it like this, but there's as a convenience, we can use defn, and that's what Clojure developers do. They use defn rather than using defn function. And it's just a nicer way to write functions. But using the building blocks of the special forms, which is def and function. Okay. Let's quit that. Yep. There we go. There we do 43. Ooh. So the yeah, so we could write individual functions for each size of arity that we've got. But if it's doing very similar things, that's kind of a very verbose way of doing things, and it doesn't really help with kind of usability of your code. So in the XChop function that they've got from the book, they're trying to describe different types of chops. So you can have a karate chop, or whatever chop type you like. So the main difference is when we're defining functions with more than one possible arity, we do have to wrap it. So in here, in this toEnthusiastic, we've got the docstring, and then we've just got the arity definition as a single vector. But in the when we're including like two different branches essentially of code. What did I do there? Oops. So we've got this. We could call XChop with 2 arguments, or we could call it with just a single argument. But this is all part of the same function definition. So we're all keeping it all together, and it's just nicer code to work with in that respect. But it does mean we do need to wrap the arguments definition and the body of that function. We end up wrapping that in another pair of parens, just so it keeps it isolated from each one. So each kind of set of parens defines the different kind of paths you can go through in this function. One thing I do encourage is to kind of put the smaller argument size first in the definition. It's just a convention, it doesn't make any difference, but that's how pretty much all of the Clojure core written. It's part of the Clojure style to do that way. We can evaluate that. So we call it, if we just call XChop with a single value, it's using the name as the default, and then if we are giving it a type of chop, then it's going to call the other path in the function, and we get a slightly different result. And what we can see is we've got a bit of a simplification of the code, because what we're doing here is we're calling When we call XChop with just a name, then we actually call XChop again. But now we're actually adding in a default style of chop. So we're defining this karate chop, so that if you don't specify the type of chop you want, you're always going to get karate. But if you do, then it's going to call this path in the function and return that way. So that's a nice way to kind of keep one function together, but call it with different numbers of arguments. And if you don't know how many arguments you're going to get, or if you want like a variable amount of arguments, you can use this ampersand in there, and it basically says whatever number of arguments you get, we're going to bind it to whippersnappers, and then we use this map function again to go over whippersnappers, and oh, that's what that does. Okay, right, yeah, I do need that. So this Clojure communication is calling the above function to do something simple with a specific whippersnapper. So however many whippersnappers we provide, it's going to tell them to get off my lawn. So here we've got yes. Here we've got 3 whippersnappers. So it's telling we get 3 messages to get off my lawn. Because we've got 3, we've got Clojure telling 3 people to get off his lawn. Okay. Interesting examples. Memorable. They're supposed to be memorable. That's why they're quirky. Okay. So lots of different options. And I think there's also, there's another example. Oh yeah, so here you can also do examples. So you can do the like any number of arguments, and then they're bound to args. Or you might want to say, okay, well, I definitely want one argument, and that should be something specific. So I'm looking for something specific to be passed. So in this case, like the name of something, and then I care less about all the other arguments. I can kind of deal with that in some other way, but so you can have one or any number of specific arguments we can define in here, and then anything else that we get, we'll just bind that up into args. But if we specify these ones in front, then they have to be there. So if here we've got 1, so we definitely have to call hello count with 1 argument. And in this case, we're passing a string in. So here we've got hello count, hello fin, you pass 3 extra arguments. So the 3 extra arguments are the ones that go into there, and the fin string is the one that goes into name. But if we just called hello count, then it's going to complain count. And you see my linter is already telling me that it's going to fail, and if I evaluate it, it's going to fail. There we go. Because we're getting the wrong arity, we expect a minimum. So again, the linter's kind of telling us that this has to be there, but then we don't have to pass in everything else, because we can basically call count args. And so we're not getting any warnings, so we can actually just pass no arguments in there if we wanted to, or any number of arguments. So that's kind of the difference there. I think we skipped over anonymous functions a little bit, so I'm just going to go back briefly. There we go. So we've seen defn, and defn is a macro of defn put together. But again, it doesn't matter if you forget that, as long as you remember you can define functions with defn, and we put like meaningful doc strings in, we put the arguments in, which can be a variety of different ways, and then we've got the body of what that function does. And if we do therefore have multiple arities that we can pass, then we have multiple bodies of the function. But sometimes we don't want a full function. Sometimes we just want to define the fn part of it. We just want the fn thing in there, and I think we can kind of, yeah, so here we're just defining a function, and this doesn't have any kind of external name. That's why it's called anonymous, because we can't refer to this outside of itself. It is kind of confusing sometimes because you can actually specify let's see, update stock. You can actually specify a name, and that confuses people as to why it's called an anonymous function when you can actually have a name inside it. But this name is local to the function itself. So if I evaluate this, I can't call update stock. That doesn't exist. That's not there. There's no symbol. There's no function name called update stock in the scope of the namespace that we're in. We can only call it from within the function itself. So we could actually have a function that calls itself. So rather than assoc here, we could call update. Oops, what did I do there? Update. And that needs to pass in a stock price. So that passes in a map. Let's pass it in for now. An empty map. There you go. Oops. Well, that is quite annoying, isn't it? Sorry. So this is actually a function, and it will evaluate because it's a function that's calling itself, and that's what we're using the name for. So this name inside the function is a way to reference calling the function again. So we're going to call, I mean, this would just go around and around in circles like crazy if we wanted to. Well, yeah, because it's just calling itself with an empty argument, which would then call itself with an empty argument. Yeah, so that would be a nice way potentially to warm up your computer. So this is a very simplistic way to write an iterative function, a recursive function, a function that's going to call itself. And this could be quite useful to work with lazy sequences. We'll see that as I assume we'll cover some lazy sequences in later examples. But the real kind of, or the most useful place that this kind of function is defined in, we saw that towards the start of the video when we were mapping over the portfolio. So we had this def portfolio, which is a vector, a collection of elements, and each element is a hash map. And so in this expression here, we want to map our function that we've defined ourselves, that's going to take the stock price and update the opening price with the latest trade. And so that's a useful use of this anonymous function. And we see we don't actually need to use the name in here because we're not going to iterate around the function. But if we had to do more work, we might want to. If each of these elements was more interesting or nested data structure, we might want to kind of iterate through each of these as well. But this is quite simple. And there's one final variation which should nicely wrap up this session. So this is quite a little bit. I mean, this is very easy to read. Hopefully, once you're familiar with the basics of Clojure. Again, we're just defining an expression, which is a function call to fn, which defines a function. So this is a function definition, just like defn, except we're not binding. We don't have the def part of it. We don't have the binding of a name to this, so it's anonymous. So but it's still the function definition, but we're just calling that in line. So it's going to call this, the map is going to call this over and over again for as many elements as it finds inside the vector of portfolio. But we can write this in a more terse, in a shorter form, which is sometimes referred to as syntactic sugar. And so instead of explicitly coming up with a name for the argument, we could actually replace that argument with, there's only one argument, so we can replace that with %. So if we select that where we're using the argument and put a placeholder in that of %. Well, let's use %1 for a moment. We can actually just get rid of the admittedly quite small boilerplate kind of code, but we can actually get rid of that part of the code now. And so I'm actually just going to do a bit of structural editing and raise that bit up there. So we just we can use just the body, and then we're using the dispatch macro inside Clojure to basically say, instead of treating this as a normal expression, we're going to treat this as a function definition. Oh, I should have changed that as well. There we go. %1. There we go. So this is now the same as the line above, and hopefully it should give the same results. Oh, yes, it does. Excellent. I'm always pleasantly surprised when live coding works. So this is just the short form of writing the above. So we're actually not having to, I mean, the advantage of this for the developers, you don't have to think of a local name. In terms of like performance and efficiency of Clojure, we're not actually generating like a local name. So there's no local, there's no bit of memory used for this local name. So potentially it can be more efficient, although in this example it wouldn't make any difference. But when you're processing large amounts of data, then it can be quite useful to do that. So it can be more readable, especially when you're comfortable with Clojure, because we're basically just looking at the body of this function. What is the body of that function? What is it going to do? And we can see with these % signs that are placeholders for the arguments. So this is where the argument's going to go in, and we're using the first argument. You can, if there's more than one argument, if there's like a second argument or a third argument, you can do that as well. And I think you can also do the Ampersand as well. So if there's all kind of like this, the same as the args approach as well. So you can have all the arguments or all the rest of the arguments. And there's another shortcut if you want to make it really small. You can remove the 1, and that defaults to just taking the first argument that's passed to the function. So again, this is a simple way to do a function definition. We're passing in the first argument in these two places, and map is going to call this as a function over the portfolio, and we get the same results. Boom. I wonder if I can I debug this? Yeah, so let's run the debugger. So I'm just going to step through what it's doing, see if it shows me what it's actually doing each time. So that's the portfolio. So that's the collection of maps, a collection of hash maps that represent my stock portfolio. And so what we're doing is we're taking the first hash map from the collection and putting it in where this % sign is. And you can see that this hash map has a ticker keyword with CRM and so on and so on. And what we're basically doing is just walking through each of those. So last trade is going to get that map, and then we pull out the last trade value, which is 23312. And then we associate that value back into the hash map. And that's the value that map will hold on to as we go through the rest of the elements in the vector. And we go through these again, we pull out the specific value and go through these over and over again until we reach the last one, and then it short circuits and puts everything back into a new data structure and returns that as the value of the value of the expression that we've called. There we go, and that's the last one. Boom. And so yeah, so then it returns those results. Simples. So that's all the different ways to use and define functions. And so mainly you're using either the defn. So if you're going to use, if you're going to call a function in many different places, or at least one other place, then you'd use defn, and that's shared within the namespace or any other namespaces that include the namespace that it's defined into. So here I've got a namespace of practically functions. So anything I define in here would be practically functions and then the function name. And so I can, if I include practically functions in a different namespace, then I can access that as long as I keep defn public. So for example, yeah, here we go. Yeah, so too enthusiastic, this would be practically functions, as you can see down the bottom of my editor and up here in the help prompt. So it's practically functions too enthusiastic. So I can use that from other namespaces if I want to. And within inside this namespace, I can use too enthusiastic because it's got the context of the namespace already. But if I just wanted something in line, if I just wanted to call something once or just in the context of iterating over a collection, then we can use the anonymous function or the short form when we're comfortable with that. And that just makes it easier. It makes it less code to read, and usually makes it a little bit easier to read once you've done a little bit of Clojure. Okay, we don't have any more questions. I think I'm going to wrap this up for the day, and then I'll do, I'll get a whole bunch of interesting examples around destructuring for the next session, which we've got here. Yeah, because destructuring is really a useful way of kind of managing the arguments, or yeah, working with the arguments of a function. And just in short, you can do positional ones. So if you're using a vector, you can kind of say, I want the arguments. You might not want the first couple of arguments for something that you're passing in, like a vector, or you might not care about the last couple of arguments. So you can kind of just choose the position or within inside a vector of what values you want. And then there's associative, which is probably more common because it is quite common to pass in a map of a hash map of values, key value pairs, and you just pull out the particular keys. And so associative destructuring will just basically, you can tell it what keys you want to get to work with from the map that you're passing as an argument, and it will return, it will kind of define those as local names that you can use inside the rest of the body of the function. So we'll cover that in lots of examples next time. Alrighty, let's go back to wrong one. No one. Oops. There we go. Fresh forms. So that's all the way down to destructuring. I don't think I've covered everything else yet, so we've covered all that. There's some of the stranger examples there, but hopefully you should be able to understand all those. And you have a look at the destructuring, but there's also a nice destructuring guide, I think, which is it's in the in here. So the Clojure.org has got a nice destructuring guide. We'll cover a lot of that in more detail. I think I do have a video. I'll put a link in to the description of this video, because I think I've done destructuring a bit before, but we'll go through some of the examples that they've covered in Brave Clojure as well. All right, well, thank you very much for listening. Again, feel free to peruse and use any of the content I've got here. Again, it's always continually in development. There's always more useful things I can add there. Hopefully going to do a little bit of work on language server protocol for Emacs and get a nice setup for there for the demos I'm using, but I've still got a lot to learn about that. And yeah, we'll keep on working on the Practicalli on the Brave Clojure Redux in the next few videos. And just check for the last few questions. Nope, that's it. Well, again, thank you very much for. Oh, it's gone dark. One more dark. I'm still here. Christ. We'll go through. Yeah, we'll go through the next bit of. Ooh, the next bit of Brave Clojure next time. So it's probably back at the normal time, but please let me know if you've got any preferences in when I do these broadcasts. I'm doing them at the weekend, but yeah, if you have any preferences of time and time zone, then let me know. And again, thank you very much for joining me, taking some time out to watch these videos, and any feedback is most welcome, so feel free to get in touch. Thank you very much. Goodbye.